Ladies and gentlemen, welcome to the main event, where in one corner we have degrees, and in the other corner we have radians. These are two ways to measure angles. And degrees is going to go head to head with radians in this video. Stay tuned. But how do we know who to vote for? How do we know who to support in this competition between degrees and radians? Well, we need to really understand what degrees is all about. So let's take a peek at what degrees are, what degrees is, what does a degree measure. Just a really simple definition, very informal. Degrees measures intensity, intensity of an angle, intensity of the temperature outside. And in a circle, like we said in the last video, there are 360 degrees. And while we're at it, we might as well say that there are 180 degrees in a triangle, something you might have learned in geometry class. In conclusion, degrees is simply a measurement, like feet or inches or hertz, to give you an example of something a little bit more unique. But what is a radian measurement? We have a radian measurement because degrees, when we measure that in an angle or in a circle or in a triangle, the whole is considered 360 degrees. To complete a full cycle around a circle, it's 360. So if we're talking about 720, we've communicated that we're doing 2 revolutions. So a radian measure, this also measures intensity. And specifically here, we're talking about the measure of an angle. The measure of an angle. And usually these measurements that we work with radians are in terms of pi. So I might as well write that. Usually in terms of pi. So if we were to convert a degree measurement of an angle into radian measurement, what will happen is it will still give us the same thing that we want. It'll still be a measure of an angle, but it will be more of a metric measurement. It's not going to be out of 360 degrees. For example, if the measure of an angle was simply pi, well, we're thinking of that in our brains as 180 degrees because it's half of a circle. But this pi we're going to start to understand as 180 degrees right off the bat. And that value of pi, though, is the value of the measure of the angle, which is approximately 3.14. So we kind of have 2 numbers in our brains that we're bouncing around, and ultimately we're going to end up using, we're going to really use that main value, that 3.14, or if it was pi over 2, it would be 1.57. That is the value of the measure of the angle. So let's get practical now. Let's take a look at how you would convert between degrees and radians. And we're going to go both ways. We're going to start with degrees to radians and then go the other way. The way that we can convert from degrees to radians is a one-step process. And we're going to do this. We're going to multiply by pi radians divided by 180 degrees. Okay, so this is a great thing to write down. And by doing this, it will take care of the units involved in each of these. So radians on the top, radians are the units, and then degrees in the denominator. So let's say we have 135 degrees. So our units is degrees, and we're going to convert. So we're going to multiply by pi radians over 180 degrees. And notice that that 135 is really in the numerator. It's divided by 1. So what we can do is just multiply straight across. So I'll jot that down. So by doing so, we'll get the correct answer. But I'm going to do a little shortcut. I'm going to manipulate this so it's easier in my brain. While I do that, the degree measurements will end up canceling. So we're going to get radians at the end, which is what we expected. And if I were to rewrite 135 degrees, that's actually 3 times 45 degrees. And we still have that pi radians in the numerator. And then in the denominator, 180 is actually 4 times 45. And now you see that little trick there. I see a 45 in the numerator that cancels with the denominator, and I end up with 3/4 pi radians. That can also be written as 3 pi over 4 radians. But what does that really mean? That means that when we wrap a radius around the circumference of a circle, we can wrap 3/4 pi of them. In other words, pi is approximately 3, so 3 times 3 is 9, a little bit more than that. And 9 divided by 4 is 2 1/4. So I could wrap 2 1/4 radii around the circumference of the circle. And that angle that's represented in that will be the measure. So that's converting degrees to radians, so let's go the other way around. To convert this way, instead of multiplying by pi radians over 180, we're going to flip it upside down. And that's really just taking advantage of the empirical method of changing units. So we're going to multiply by 180 divided by pi radians. So let's say we have an angle measure that's 7 pi over 6. All right, so a little bit difficult to really comprehend here. What does that even mean? It means we're going slightly more than pi radians, so 7/6, 1 point something. All right, just change the colors there so you could see. All right, so we're multiplying by 180 degrees divided by pi radians because 180 is pi radians. And so what happens there is the radians divide out, and our answer is going to be in terms of degrees. And now you wouldn't have to write every single detail of this, but I'm going to just write out 7 pi, and I'm going to factor out 180 to be 6 times 30 degrees. And I'm leaving the units there. And then what you can notice is that the 6 divides out. So we end up getting 30 times 7, which is 210. Oh, one thing. Oops, I just included this pi here. Obviously the pi's cancel out. You probably noticed that. Pi's cancel out. We have a 7 here. 7 times 30 degrees is 210 degrees. Well, what is 210 degrees? Well, 210 degrees is slightly more than 180 degrees. In fact, it's 30 degrees more. So it's a little bit past halfway around a circle. And remember when I said 7 pi over 6 is slightly more than pi because 7/6 is slightly more than 1. So that makes sense that they would both be past 180 degrees or half of a circle. All right, so now that we know how to convert measurements between degrees and radians and vice versa, let's take a look at one final thing. It has to do with the length of a portion of a circumference, and it's called arc length. So the arc length of a circle is just a portion of the circle's circumference. And I'm just going to share a formula with you, and we're going to take a formulaic approach for now, and we could get a little bit more conceptual later or find out other ways. And the formula for arc length is S equals R times theta. All right, so that symbol is a Greek letter called theta. And the S right there is representing arc length. And you know that R means radius. There's one requirement though. The requirement is that theta, or if we call it alpha or any other Greek letter, we usually use Greek letters for angles. The requirement is that theta must be in radians. So now you can see why we converted that measurement. If we're given a measurement like 30 degrees, like in the example that I shared with you, my location, then I need to convert that to find out the arc length, the distance between the equator and my location in a northerly distance. So how far am I from the equator? I could use arc length. In fact, let's do that. So recall that the actual theta measurement that I used a moment ago, actually, was this in the last video? It was in the last video. Okay, so what I figured out was that my location, GPS coordinates, was that I was 30 degrees north, approximately. I'll leave off the minutes and the seconds. 30 degrees north. And now I had to do a little bit of research, or maybe just recall that the radius of the Earth is approximately 4,000 miles. To be a little bit more precise, it's 3,959 miles, and I could think about that in kilometers as well. But that's the information that I need for this particular problem, and we're looking for the arc length. In other words, the distance along the surface of the Earth, which is a circular sphere, we're just thinking about it in 2 dimensions for now, just my location north of there. So the first thing I need to do in order to use that formula is I need to convert 30 degrees into radians. So I'm going to multiply by pi radians divided by 180. The degrees cancel like we did before. I'm going to do this mostly in my head or just a little bit on paper here. That the zeros cancel, and how many 3's are in 18? Well, there are 6 of them. So the angle measurement theta is equal to pi radians over 6. Pi radians over 6, or pi over 6 radians, okay? Now we could actually use that formula, okay? So S equals R times theta. S is equal to 4,000 times theta, which is pi over 6. And notice how I'm writing these fractions, like 4,000 is in the numerator, so I'm writing that in line with pi. And I'm just going to leave out the actual units, because we know that the units are in miles, and the units of our final measurement are not actually going to be in radians. That's just allowing us to find out what portion of that. It's really a ratio, in a sort of way, of the entire radius. Okay, so I know that I can factor out a 2 out of 6, and I can factor out a 2 out of 4,000, which becomes 2,000 pi over 3, and that's in miles. So the formula takes on the units of the actual radius. And if I use 3.14 for pi, just a really simple calculation on my calculator, I get 2,093.3 miles. To help visualize this, just this one last thought, and we'll wrap it up here. Just a quick picture for you so you could see what this would look like if we were to sketch a simple picture of the Earth and then a 30-degree angle. So there's the angle, and this arc length here is called S, and I could just draw these lines to indicate that that's that value. And where am I? Well, I am located standing on that red point right there. So for future problems about arc length, what you could do first is you could actually draw the picture so you could understand what's going on from there, and then start to work the formula to see that it makes sense in context. All right, hey, well, there's the Earth, there am I, there I am, and I hope you're doing well. Thanks so much for watching. Bye-bye.